A blockchain is a decentralized and distributed digital ledger that records transactions across many computers so that the registered transactions cannot be altered retroactively without altering all subsequent blocks. A peer-to-peer network creates nodes that can connect directly with other nodes, known as peers. These peers could then also form relationships with others and create new blocks with information on transactions to add to the chain. Data isn't stored in one place, but spread over numerous computers worldwide. When a new transaction occurs, it is broadcast across the various peer-to-peer nodes. Each node collects the transactions that have occurred and begin calculating a hash value, otherwise known as a digest. The hash value is then stored along with the transaction to create a block. Allowing blocks to be added sequentially ensures that falsified transactions cannot be added to the blockchain. As an additional security measure, each block also contains an encrypted hash, which links each block in the chain and its preceding block. This means that altering a transaction in a block or changing the order in which blocks are added would also alter the hash value of the preceding blocks, making this effort a waste of time. The accuracy of blockchain technology is based on the fact that all peers and participants in a network must hold multiple copies of the blockchain. Any change made to one copy will affect all other copies within seconds. This ensures that when new transactions occur, they are accurate across all peers and participants, meaning they can be trusted as accurate representations of actual transactions. Append-only data storage. The reason why we want a blockchain is to ensure the permanency of transaction data. When a block is added to the chain, it contains a hash of all previous blocks. Because the data in new blocks are linked back to older ones, the only way to change an entry in one block is if you make changes throughout all subsequent blocks. On a blockchain, data does not reside in a conventional database. The data stored in a blockchain cannot be altered in any way. This is feasible since the blockchain database can only be updated by adding new blocks. After the data relating to a transaction has been saved in a blockchain, in the form of a block, that data cannot be changed or edited in any way. This is basically what this means. Consequently, any transactions of this kind are protected from being tampered with. But wait. The hole in the ground is significantly more profound. The storing of data on a blockchain involves a lot of different considerations. Primarily, what information will be stored on the blockchain, and how will it be stored? Smart contracts. A smart contract is a computer protocol intended to digitally facilitate, verify, or enforce the negotiation or performance of a contract. Smart contracts allow the performance of credible transactions without third parties. These self-executing contracts automatically implement themselves and execute when specific conditions are met. The most prominent example of such a smart contract was the DAO, Decentralized Autonomous Organization, encouraged users to contribute funds that would be used to support various projects. The DAO was touted as a game-changing application of blockchain technology. Unfortunately, the DAO had a serious programming flaw that allowed hackers to siphon away more than $50 million worth of Ether. Eventually, the loophole was identified, and a controversial fork in the Ethereum source code was created to recover the lost funds. A smart contract is essentially an algorithm that processes and interprets contracts or agreements written in computer languages known as smart contract codes. On the other hand, a blockchain is a public ledger of all transactions that have ever been executed. It constantly grows as completed blocks are added with a new set of recordings. The blocks are added to the blockchain in linear, chronological order through cryptography, and each block is connected to the preceding one via a hash. Each node, computer, on the network has a copy of the blockchain, which gets downloaded automatically upon joining the blockchain network. Hashing. In cryptography, a hash function is any function that can be used to map data of arbitrary size to data of fixed size. A hash function has two important properties. It must be easy to compute the hash of any given data in the set, but hard to find data that maps to a given hash. Most commonly, this is done by transforming the input information into a string with a fixed length, for example, 32 or 256 bits per block on an Ethereum blockchain. Storing data on a blockchain includes a step called hashing as one of its components. The data added to a blockchain is hashed or otherwise converted into a string of texts before it is added. After that, they are encrypted and added to the blockchain for storage. You will need to use the same hashing procedure to decrypt and gain access to that data. When information is saved on a blockchain, there is an increase in the significance of two terms. The private key and the public key are their respective names. Transactions that use the private key cannot be altered in any way without the owner's express permission. It is necessary to have the public key to send transactions over the internet. When someone wants to send transactions or verify previous ones, they need both keys. Procedures of writing and storing data on blockchain. The blockchain is exactly what it implies, a chain of blocks. Each block contains information about a transaction and a reference to the previous block. As explained before, no two blocks can contain the same data. Each block, therefore, needs to be secured in some way. This is the main reason we have encryption, to begin with, and hash functions implemented on top of that. We call this the process of writing and storing data on a blockchain. Examine the information contained on a blockchain regarding the transactions. This will provide insight into how data is stored on the blockchain. It will only store the information relevant to the transactions and will not store any personal or sensitive data or information. By studying the different types of file formats, it is also possible to acquire the knowledge necessary to write and store data on a blockchain. The ubiquitous binary format for storing blockchain data was developed to facilitate user interaction with distributed ledgers. Users are not required to download or install any specialized software to interact. Learning about the bits used in each transaction is another method for understanding how data is stored on blockchains. Because multiple transactions are recorded every second, it will be extremely difficult for someone to hack into your records because each bit comes with more than 1 million different possible combinations. Decoding the process by which data is created and stored on blockchains can also be done by examining the time it takes for blocks to be created. The creation of a block can take anywhere from 10 to 30 minutes. Anyone interested in breaking into your Bitcoin blockchain must mine one block within milliseconds of starting their attack. Conclusion: the use of blockchain technology has expanded since its inception. As we are still learning about the potential benefits and issues of this new method for storing, trading, and managing data, there is little doubt that it will gradually become more integrated into our daily lives. There are still many more areas that need to be explored further to understand the potential impacts and benefits of the technology.